In this video, we will review sections 19 and 20. So make sure, take a look. 19, we're going to simplify completely or perform the operations and simplify. First two are just simplify. That is the cube root of negative 27a to the fourth b to the eighth. Now we got a whole bunch of operation problems to go through. And then section 20, we are going to rationalize the denominator and simplify, and we have these three problems. So pause, do them yourself, and now I'm going to get to work. So number one, simplify completely. I come up here, I'm looking at the square root of 16x to the fifth y squared. 16 is a perfect square, that's a 4. X to the fifth, I like the rational exponents, everybody. This is the square root, so I'm going to look at 5 divided by 2 is 2 with a remainder of 1, which means an x squared is coming out, and it means I have an x to the first left under the radical. And then for y, well, this one, don't overthink it, everybody. This one is so perfectly set up. The square root of y squared is just a clean y. But certainly if you're that creature of habit, 2 divided by 2 is 1 with a remainder of 0. So y to the first out, no y's left behind. 4x squared y times the square root of x. Next one, cube root. I've got the cube root of negative 27 a to the fourth b to the negative 8. Well, negative 27 is negative 3 cubed. So once again, just like the 16, that was a perfect square, definitely taking advantage. This is a perfect cube. So I'm going to get a negative 3 out in front. But then for the a, I'm looking at 4 divided by 3 is 1 with a remainder of 1. For b, I'm going to do 8 divided by 3 is 2 with a remainder of 2. So that means for a, an a to the first came out, and then for b, a b squared came out, but then I still had an a to the first left behind, and I still had a b squared left behind under my radical. Negative 3 a to the first b squared times the cube root of a b squared. Again, other people, just slight differences. A to the fourth is a cubed times a, so they could do the cube root of a cubed. B to the eighth is b cubed, b squared. The two b cubes you could take the radical of, the b squared gets left behind. Number 3, now I'm multiplying. Negative 10 times 2 is negative 20. 8 times 3 under the radical is a 24. But of course, I'm still looking to simplify. I know 24 is 4 times 6. A 2 comes out. Multiplied by the negative 20 gives me a negative 40. And the 6 is left behind. Negative 40 radical 6. Number 4, well, now I've got to distribute. I get 7 radical 50, multiplying these two. 7 pushes along. Radical 5, radical 10 gives me the radical 50, minus 35 radical 5. 7 times 5 gives me the 35. This times the radical pushes along. This can keep going. 50 is 25 times 2. Square root of 25 is a 5. 5 to the front makes that a 35. I'm getting 35 square root of 2 from here, minus 35 radical 5 from here. Number 5, addition, subtraction. I do see some like terms here, but I'm going to focus here first. I'm looking to simplify. I see 12 is 4 times 3, so that became minus 2 radical 3. Now I see, okay, I've got like terms here and here, and I also have like terms here and here. These two, I'm getting an 11 radical 5. These two, I'm getting a plus 6 radical 3. Coming over here, again, addition, subtraction, I don't see any like terms, but once again, I need to do some cleanup. I look at 200, I see that as 100 times 2, so that becomes 10 times the square root of 2. This 2's hanging out. 32 is 16 times 2. Square root of 16 is a 4. 4 coming to the front. It's not a 24. It's 2 times 4. Gives me an 8. So I've got an 8 radical 2 from here. And that minus 7 radical 2 is still there. Well, now just keep going. 10 radical 2 plus 8 they're all like terms, I should point out. So 10 radical 2 plus 8 radical 2 is 18 radical 2 minus 7 radical 2 equals 11 radical 2. Now I need to distribute over here. I'm going 20 times 12, radical 20 times radical 12. I'm getting radical, let's see, 20 and 12. I'm getting 240. Plus 20 times 5, I'm getting radical 100. 3 times 12, I'm getting radical 36. And then 3 times 5, don't lose the minus, but now I'm getting a radical 15. Well, let's start thinking. What do we have here? Well, 36 is a perfect square. That's a clean 6. The radical 15, that's not going anywhere. The 100, that's a clean 10. What about the 240? Well, we can think about it for a moment. Quick, I'm trying a few different things. I can quickly see a 4 works. 240 divided by 4 is a 60. But then I'd realize, wait, I could still keep going with a 60, so maybe try something bigger. And again, folks, I'm not just doing every factoring pair. I'm not going, well, does 3 go in? I only care about perfect squares. Does 9 go in? No, it does not. Does 16 go into it? Ah, it does. So instead of doing 4 times 60, think of it as 16 times 15. Square root of 16 is 4. So I got a 4 radical 15 here. I got a 10 from here, a 6 from here, and the minus radical 15 here. Look at my like terms. 4 radical 15 minus radical 15 is 3 radical 15. And the 10 plus 6 is 16. Number 8. Some people might notice, hey, those are conjugates. But for most of us, just taking a straightforward multiplication, distributing, just like we did over here. Rad 7 times rad 7 is 7. Rad 7 times 9 is 9 rad 7. Minus 9 times rad 7 is minus 9 rad 7. And minus 9 times 9 is minus 81. So I just multiplied, but especially if you noticed it was a conjugate, you expect more stuff to happen. But even if you didn't notice the conjugate, we're still looking. And not only do I see like terms here, I see that they cancel. And then the 7 minus 81, I'm getting a negative 74. 2 more here. How do I square this? Well, there is no shortcut. I got to write it out. I got to do 3 radical 6 minus 4 times 3 radical 6 minus 4. And now I'm foiling this just like we were back here. Distributing here times here. 3 times 3 is 9. Rad 6 times rad 6 is 6. 9 times 6 gives me 45. No problem in doing a couple of steps to get there, folks. Again, this is the review. I'm kind of just jumping along, but make sure you're doing what you need to. 3 radical 6 times minus 4 is minus 12 radical 6. Here I got another minus 12 radical 6. And I got a 16. 45 plus 16 is 61. And these two combine to minus 24 radical 6. Last one from section 19. Last distribution. this, and this, and then this times this. I'm getting a 4 radical 15 here, minus rad 3 times rad 3 is 3, so I'm getting a 12. That 4 is still there. 4 times radical 9, 4 times 3 is 12. Then here, I'm getting minus 2 radical 35. And then here times here, I'm getting plus 2 radical 21. And that's it. I look across, and again, good examples. We've seen plenty where lots of stuff simplifies and combines. Some stuff cancels. A little bit cleans up and combines. Here, nothing cleans up, nothing combines. Radical 15, can't do anything with that. Radical 35, radical 21. None of them are simplifying. None of them are like terms. That is my final answer. Now moving into section 20, rationalize the denominator. Number 1, the single term. How do I clean up a square root of 7 in the denominator? I'll multiply denominator by square root of 7. Whatever I do to the bottom, I do to the top. The bottom must clean up, and it does. I get a radical 49, which is a 7, and on top, I get 2 radical 35. Nothing cleans up there. I'm finished. That's number 1. Here, well, now it's a compound term, a binomial, so I will use its conjugate. The conjugate will be radical 3 minus rad 2, and whatever I do to the bottom, I do to the top. That's the idea. Same idea here and here, just that you need the conjugate to make everything work nicely. Clean up the bottom. Rad 3 times rad 3 is 3. I get a minus radical 6. I get a plus radical 6. And I get a minus 2. These cancel, and 3 minus 2 equals 1. My denominator is 1. On top, 4 times radical 9, or 4 times 3 is 12, minus this times this, 4 radical 6. And especially here, because it's over 1, wouldn't be at all surprised to just see a lot of people just write that as 12 minus 4 radical 6. Last one. One more conjugate. And again, it's not about the top. Tempting to think about 1 plus radical 5, but that doesn't help. We're cleaning up the denominator. I'll need radical 6 minus 2 to make that happen. In the denominator, I'm getting rad 6 times rad 6 is 6. I'm getting a minus 2 rad 6, a plus 2 rad 6, and a minus 4. These cancel. 6 minus 4 gives me a 2. On top, 1 times rad 6 is rad 6. 1 times minus 2 is minus 2. Minus rad 5 times rad 6 is minus radical 30. And minus 5, radical 5 times minus 2 is plus 2 radical 5. Nothing cleans up. No combination, nothing extra here, no simplifying. So radical 6 minus 2 minus radical 30 plus 2 radical 5 all over 2 for your final answer.